Hi, my name is Jeff Lang. I'm a senior project leader here at Aerospace. I helped out creating the CubiKit, and I'm going to show you how to assemble it, so let's jump in. All right, let's go through the supplies list. First thing I'm going to start with is a cardboard box. This will be the structure of your CubiKit, and you can print out a template and cut out the cardboard box. Next thing we'll talk about is the single board computer. This is an ESP32. This is kind of the brains of the kit. We also have an A to D converter. This will take the analog signal from the photocell and convert it into a digital signal that the single board computer will understand. The next thing that we have is the photocell that we'll use to detect our simulated sun. The next thing that we have is a single 1 kilo ohm resistor. This is going to go in parallel to the photocell. We also have the motor driver. This will be what we use to drive the wheel on the bottom that will spin the CubiKit. We also have the IMU board. This is used for sensing the rotation of the CubiKit. We have a couple of solar cells that get stuck on the outside of the structure for looks. We have some scissors that we're going to use to cut out the template out of the cardboard box. We have a motor that we're going to use to drive the wheel on the bottom of the CubiKit to spin it. We have a wheel that is going to go on the bottom of the CubiKit in order to spin it. We have a DC-DC buck converter that will take the battery input and regulate it to the 5 volts that the single board computer wants. We have a pigtail to a 9-volt battery that includes a little push button switch. We have 3 I2C cables that we're going to use to connect the boards together. And we also have a hot glue gun that we're going to use to fasten the components to the cardboard. And a wire stripper. So the last thing that we have is a flathead screwdriver that we're going to use for the terminal blocks on the A to D and on the motor driver. So first thing we're going to do is use the printout template and cut out the cardboard box, and I'll meet you back here once I've done that. So I just got done cutting out my cardboard template and the lid. So the first thing that we're going to do is we're going to glue the motor to the bottom of the cardboard template, making sure we get it as flat as we can against the cardboard, and making sure that the output shaft lines up with the center of the hole in the bottom of the cardboard. So we have our hot glue gun ready to go. We're going to put a little bit on the bottom of the motor, making sure that we don't get it in the way of the output shaft. We're going to line that up so that the output shaft is at the center of the hole in the bottom. Now that we've glued down our motor, we're going to continue on to the A to D. First thing we're going to do is we're going to loosen up the leftmost 3 terminal screws with our little flathead screwdriver. That's the ground, the voltage, and the A0 terminals. We're going to take the photocell and we're going to put it into the 2nd and the 3rd terminals from the left, voltage and A0 terminals, and we're going to tighten down the center terminal to hold that in place. Next, we're going to take our resistor and we'll bend the wires so that they're parallel to each other to make it easier to put into the terminal. And we're going to put that into the ground pin terminal and the A0 terminal. So the first one and third one from the left. And then we're going to tighten that down. We can pull on them to check and make sure that they're in there. Okay. The next thing I'm going to do is I'm going to bend the resistor away from the photo cell so that it doesn't accidentally short against the voltage pin. And then I'm going to bend the photo cell into a little loop, and that way it'll stick through the box when we glue it down to the box. Next, I'm going to take the A to D and I'm going to apply a little X of glue to the back. And I'm going to glue it just under the hole in the box so that the photocell points through that hole. For the next couple components, we want to make sure that they don't interfere with the creases in the box when we fold it. So we'll go ahead and put some fold lines in there so that we can see where those are. Now we're going to glue the motor driver in place. I'll use the same approach where I put a X of glue on the back. And I'm going to stick it down with the 4-terminal block towards the bottom of the box. Okay, next we will connect the motor to the motor controller. We're going to connect the red and the black wires with the red on the leftmost terminal and the black on the second from the left terminal. We can slide them in there and tighten the screws down. Okay, next we will glue the single board computer down, and this can go pretty much anywhere in this area. About halfway up is good so that the wires all reach. And stick it down. Note that we're putting the USB connector downwards and that it doesn't interfere with the folds in the box. Next thing we'll do is we'll glue down the 12-volt buck converter. And we're going to stick it on this left panel, making sure that it's to the left side of the panel over here so it doesn't interfere with the motor. And we want to make sure when we glue the converter down that the wires are facing up. That'll make it easier to reach it to the motor controller later. So now that you've glued down the DC converter, we're going to use our wire strippers and we're going to expose a little bit more wire on the input wires here. Now we can take those wires and we can put them into the 2-pin terminal of our motor controller. First we'll loosen up the terminal block. And we're going to insert them with the red one on the left and the black one on the right. Before we tighten it down though, we'll take our 9-volt battery pigtail, and if you need to expose some more wire, use those strippers for that, but this one has enough wire exposed that I can just insert this in alongside those other 2 wires, keeping the polarity the same, so black to black, red to red. And then we can tighten that down. And give them a tug and make sure that they're in there. Alright, now we'll use the I2C cables that we've got here and we'll connect all these boards together. So the first one we're going to connect is the A to D to the single board computer. Okay, next we'll use the other short one and we'll connect the A to D to the motor controller. Next, what we're going to do is we're going to glue the IMU to the center of the top of the CubiKit. We want to make sure that the coordinate system is correct when we glue it on. So if you look on the top of the board, you'll see a coordinate system, and we want to make sure that when we glue it, Y is down and X is to the right. Alright, so we're going to glue the IMU to the top of the CubiKit, making sure that the Y coordinate system points to the side that will be joined to the back of our CubiKit. And we want to make sure that we put it at the center of our panel. Okay, next we can use our long I2C cable, connect it to the motor controller and to the IMU. Now we can connect our USB cable to the USB plug on the single board computer. And the wiring is all done. So originally we designed the CubiKit to use a 9-volt battery, but found that the LiPo battery works better. So I'm going to describe to you now how to set up a conversion to use a LiPo battery. The first thing that you'll need for this is a set of wire strippers, and you'll also need a JST connector that goes from the battery, and next you'll need a 9-volt pigtail. We also have our LiPo battery. Now to hold the LiPo battery into the CubiKit, we're using these little squares of Velcro. And then for final assembly of the CubiKit, we're using this clear packaging tape. So let's get started building our adapter. Okay, so first thing we're going to do here is we're going to strip back some of the wire insulation so that we can connect these two together. We'll use our wire strippers to do that. Okay, once we've stripped back the insulation, we're going to connect these together. Now because we're using the 9-volt pigtail as an adapter, we're actually going to connect the polarity backwards. We're going to connect the red to the black and the black to the red. And we'll just twist those wires together. Now in order to keep them from shorting against each other, we'll just put a little piece of tape over each of them as well. You can use electrical tape or masking tape. In this case, I'm just going to use the packaging tape that I have on hand. And that'll keep them apart. Now we can go ahead and finish assembling our CubiKit with our new pigtail. Okay, so now we've got our pigtail made that's going to adapt our LiPo battery to our CubiKit. What I'm going to do is I'm going to put a little piece of sticky back Velcro onto the CubiKit to hold the battery in place so it doesn't slide around while this is spinning. I'm going to also connect up the pigtail that we made to the 9-volt plug here. And we want to make sure also that the pigtail goes positive to negative, negative to positive here. And then finally we can plug in our LiPo battery. And if we want to check and make sure that everything is connected, we can click the button and we should see lights come on. Now before this kit will do anything, we need to upload the Arduino code to it, which we'll do in the next step. Alright, before the CubiKit will do anything, we need to upload our code to it. We'll do that by unplugging the power from the bottom USB port on the single board computer. We're going to plug in our USB-C cable where that was. And we're going to plug the other end into our computer. And now we'll continue on the computer. Okay, so now that you've got your CubiKit built, the next thing we need to do is upload the software to it. We're going to do this using the Arduino IDE. First thing we're going to do is we're going to download the Arduino IDE installer. You can do that through the link here for Windows and the link here for Mac. We'll go ahead and do that right now. While that's downloading, I want to mention that we are using the Arduino 1.8 rather than version 2. And the reason for that is because the SPIFS file uploader does not work currently on version 2. So once Arduino is downloaded, we can go ahead and double-click it to install it. We can say, I agree, hit next, and install. And once that's done installing, you can go ahead and hit close. The next thing that we need to do is install the drivers for the ESP32 to talk to the computer. We can download the installer by clicking the link here for the executable for Windows, or the link here to download the zip file for Mac. That's going to open up a web page, and the download button is right here. Once that's downloaded, go ahead and double click on the executable and go ahead and hit the install button. And go ahead and hit OK. Now you can exit out of that. Okay, the next thing we need to do is install some modules. The first one we're going to install is the SPI flash file system. Let's download that using the zip file link in the sheet. Now, in order to install that, we're going to open up our Documents folder. And inside there should be a folder called Arduino that was created when we installed the IDE. And this tool goes in the Tools folder. We'll double-click on the zip file and drag the folder into our Tools folder. And then we can go back out. Next, we're going to download the ESP async web server, and we'll also downlink the async TCP. Now these two go in our libraries folder. Again, we'll double click on the zip file and we'll grab the contents and put it in there. And we can go back out. And now we're done with this one, so we can close it. The next thing we need to do is install some libraries with the Arduino IDE itself. So we're going to open that up. We're going to go to Tools. We're going to go to Manage Libraries. We'll give it a second to download all the libraries. And we're going to search for Arduino JSON, and we'll click on that and install that. The next one we're going to install is the SparkFun ADS 1015. We'll search for that, and again, we'll hit install. Next, we'll install the IMU. Hit install. And last, we'll do the serial motor driver and install. Once that's done, we can close this. And the last thing that we need to do here is we need to install the board itself. So we're going to take this link and copy it. We're going to go into File, Preferences, and down here at the bottom, we're going to add it in here. In mine, it already happens to be there, so I don't need to do anything. On yours, if this is blank, you can paste it in there. Or if you have a different link in here, you can add a comma and then paste it behind that. Once we've done that, we'll say OK. And then we're going to go into Tools, Boards, Tools, Boards, Boards Manager. And we're going to type in here ESP32. And this is the one that we want here, the one that says by Espressif Systems. and mine already happens to be installed. Once we're done installing that, we can hit close, and now we want to select that board, ESP32, all the way down here, the SparkFun ESP32 Thing Plus C. So next, we can plug our USB-C cable into our computer and into the ESP32 that's inside of our CubiKit. And you should see a blue light flashing on the front of the board, indicating that it's got a connection. Once again, we'll come in here to Tools, and we'll have to select the port, and mine showed up on COM port 5. If you have multiple COM ports listed here, it's probably the one with the highest number. Go ahead and select that. Next thing that we're going to do is we're going to open up the sketch. Now I've saved mine in my Downloads folder, in this folder called STEMKit ESP32 Thing Plus _R9. I have a .ino file and a data folder. In the Arduino IDE, I'll go to File, Open, and I'm going to browse to my Downloads folder and into the folder where I saved the INO file. I will select it and hit Open. You'll notice it opens up a new window here. We can actually close the original one and just keep working with the new one here. Once we've got the file open, the next thing that we'll do is we'll upload this data folder to the ESP32. To do that, we're going to go to Tools, ESP32 Sketch Data Upload, and you'll notice that it's doing it. Once it's done, you can tell it's done here because it says that an image is uploaded. Once it's done, we can then go and click this arrow button to upload the sketch itself to the ESP32. And it might take a little bit for it to compile and upload. Once it's done uploading, you'll see the message done uploading. And you can now go ahead and close down the Arduino IDE and unplug the ESP32 from your computer, and again plug it into the DC power supply that's inside the CubiKit. Once we've plugged in the battery and turned on the CubiKit, we can then go to connect to it. We'll go to our Wi-Fi settings and we'll select the CubiKit address and hit connect. Once we've connected to the network of our CubiKit, we can then open up a browser and we can connect to the CubiKit address. Once we're connected to the home screen of the CubiKit, we'll see the data coming in. If we point the photocell towards the light, we'll see the power change. We'll see the photocell light intensity change. And as we move it around, we'll see the IMU acceleration and IMU gyro values change, as well as the IMU magnetometer. There's a couple of different modes that we can access on the CubiKit by using these different addresses. We can put it into mode normal, where it tracks the sun as normal. We can put it into safe mode, where it disables the motors. We can put it into the simulate error mode, where it introduces a random error on the photocell. And then we can also put it in solar panel tracking mode. Now that we've finished uploading the code to the CubiKit, we're going to plug our power back in. If you're having trouble uploading your code to the single board computer, try pushing this bottom button to reboot it. And we're going to continue folding it up. And we'll leave the door untaped so that we can open it for later to get to the components. Now on the top, we want the wire to come out the left-hand side, and we'll insert it that way. So now that we've got it all taped up, we can glue our solar panels on the side with the photodiode. A little X of glue on the back. Just place it in the center. And the second one right on top. And the last thing that we'll do is we'll put the wheel on the bottom. There's a notch that you need to line up in the wheel and on the shaft. And I like to hold the back of it as I'm pushing it on so I don't push the bottom in. And you don't need to put it on all the way, just enough to where it grabs. Wherever it is, there it is. So once we've got the wheel on, we can put a little rubber band around the top to keep the door shut. And there you go. The CubiKit is now assembled and ready for fun.